Hey, EE1520 student, when you watch this recorded video, I will be probably on the plane. So that's why I have to pre-record this, and you will be seeing this, I believe, on March 11th, Taiwan time. Okay. Um, so let me try to. Okay, the first thing I should announce, now we have a Discord group. I just want to recap what we have done so far this semester. We first talked about a concept called addressable memory boxes. And then we talk about some basic operating system architecture. Particularly, we present the concept of a virtual memory, and we use a 2C program actually to show how you can validate or verify the concept about virtual memory address layout on your own machine, which is important because we want to have the capability to always validate with a program, particularly in C or C++. And also, we talk about installation of Ubuntu and WSL, Windows subsystem for Linux. Um, at this point, we really hope that you um, will have access reliably a Unix environment, either a MacBook or Ubuntu. For the rest of the semester, whenever we show you some kind of demonstration, it should be able to run on either one of those. Okay, both of those actually. Okay, and there are a lot of topic about operating system which we can only cover minimal to enable you to be able to learn some of the concept for the rest of the semester. When opportunity arise, I will introduce you more topic, especially when we talk about GPU programming. You need to have some extra stuff about operating system, but we will deal with that later. At this moment, if you understand the basic concept we cover in the class, that should be good enough. Okay. And then last time we talked about the concept of a separate compilation. We use the example stack underscore 01.c. As example, you can split a program into different source code and you can compile them separately. You for software development process that this is a good habit enable us to deal with each of the module in each of the file, and then we can integrate them together. And in particularly, we present a particular tool called make or makefile, which we use make and makefile to define what should be the compilation process such that you can generate the executable file from a bunch of file and you can specify you just simply need to take type make and it will automatically take care all the rules. So Makefile is what we call a rule-based program. So it's not like a procedure program. You go through a sequence of instruction, but instead, Makefile is a rule-based programming. Essentially, you have a bunch of rule. Which rule to be triggered, it will depend on what's going on in the previous rule. All right. So I hope you have already gone through the example how we wrote a makefile for stack 01.c and in is a separated form. and also you know how to use this make file to produce executable. If you haven't learned that, that's okay. You will see a lot more example, including today. All right. If you have any question, please ask me either via Discord or you can talk to me on Thursday when I get back to Taiwan. Okay, so today we're officially go into the core about this course. It's called object-oriented programming. Um, Before I talk about object-oriented programming in C++, I'm going to talk about a very important object representation language called JSON. JSON stands for JavaScript Object Notation. It's really help us to represent the data that we would like to represent and capture, and also to have a program to operate through this object. So essentially, when you think about what is object-oriented programming, it's not just using a programming language called Python or C++ or Java to solve a problem that you would have solved it using other language such as C itself. But more importantly, object-oriented programming is a modeling. You try to solve a problem in a different approach. So in the traditional programming, we're saying that okay, we're solving a particular problem, and then we think about what is the shortest path go between Tainan to Taipei, for example. But object-oriented programming, the first thing is you have to know what's the object in that you care about. Okay, so essentially you think about real world, you can view everything, regardless physical thing or virtual thing, as object. So just go back to the topic when we talk about virtual memory management. In the implementation of virtual memory management, we actually call a memory object. So every chunk of memory allocate to certain memory layout. Each of them internally object operating system, we call a memory object. So you can see that the concept object is everywhere, very pervasive in our life, also in both physical world and in the cyber world. And that's what we're going to think about. So you're not thinking about, oh, how I'm going to write a single program to deal with all the objects. In object-oriented programming, I want you to know this is very important, is that what you need to learn is, well, how do I represent the object in the system I try to deal with? And then you're going to write a program about how each of the objects are going to interact with other objects. Okay, this is a very important. A lot of people learning object-oriented programming language, they got it wrong. Usually you learn programming language, you say, okay, I'm going to using this language to solve a particular problem. No, that's not right. That's not the main purpose of object-oriented programming. Object-oriented programming is how do you represent the object? That's why we want to learn JSON or learn object-oriented data representation. You want to know how to represent each of the individual object. And then in a programming language like Python or C++, you worry about how objects might interact with each other. So it could be an object that in your smartphone is actually interacting with another object in Google server. For example, in the Google server, you have a bunch of email, and in your local machine, which is your phone, you're trying to cache or download a small portion of object from that email. So in that sense, every single email is an object as well. So essentially, when you're looking at object-oriented programming, everything is an object. Everything you can think about, whatever things you want to model is an object. Okay, so we're going to start it with what I call object-oriented data representation. And then we can actually gradually learn about the C++ program, how they will interact with such an object model. Okay, so my object is JSON today. Okay, I'm going to use this as an example. I know is a toy example, but I think is kind of interesting. So here's a picture. You go to a grocery store, and then you saw a lot of product. Okay, so I'm going to challenge you. Okay, when I look at this, you actually might not know what problem you try to solve, right? I mean, why I'm showing you a rack or some kind of refrigerator area that's actually contain certain kind of product, right? So what's the problem to solve? I don't know. I mean, I have something in mind, but you might have something in mind. But I want to separate this is that on one thing is that what is the problem a programming language try to solve, or versus here's just a problem. And I don't have a specific about the problem. My only problem is the world I'm dealing with have a lot of object, and how do I represent this object? Okay, I mean these two things go hand in hand. Okay, sometimes if you represent the object nicely in a good way, then it's very easy for you to use this representation to solve a lot of problems. I mean, let me just point out what kind of problem we can solve. For example, this picture involve, okay, maybe it's an inventory. I mean, how much copy or how much bottles of certain drinks that I have in my store. That could be one type of problem. But the other problem is, well, how many of those bottles they're going to expire? Or the other problem is that in this picture, you can see this is all beer, alcohol. And then I have to worry about, well, who can access to this beer? I'm not sure about Taiwan, to be honest, but in US, you have to be 21 years old to purchase some of this product. And the thing is that the other question I want to ask you, if a customer coming to grab this product is a pregnant woman, then basically is a ethical issue to ask if a pregnant woman should be allowed to buy alcohol product. You can see that there's a lots of questions. You can continue this list. It's really interesting. Sometimes if you go through, I just show you a picture. You're not trying to tell me what that picture is. Instead, in object-oriented programming, you should think about, okay, in this picture, what are the objects? Then you think about, well, what kind of problem I want to be able to answer related to this objects. I just show you an example about the freshness, the store inventory issue, the alcohol addiction issue, the minority should not drinking the alcohol, or whether a pregnant should be protected from having an alcohol drink. Okay, the other thing which is important, by the way, the reason I actually present this picture initially, it was the time when Google started to look at the concept of smart fridge. So smart fridge is trying to have a refrigerator at home to help us or help Google to capture more information about our privacy. to look at, what kind of product you have in your refrigerator. They gather all this information. They decide, okay, what's the need about our community, say Tainan City. And then from there, they decide, okay, whether I should sell this information to a particular store, for example, Quanlian, to ask them, I think that you should actually buy more of this product because this community, they're interested in this particular type of product during this time. Okay, you can think about this. This could go really deep into that. But the fundamental issue we need to worry about is, well, how do I represent each of the object? So now we're going to look at this issue today. Okay, the first I'm just using an example. I'm using this particular brand of beer called Beck's. Okay, this is a one of the. Is that in this picture somewhere? I'm not sure actually. Okay, but assuming this particular box of beer it was actually in that picture. So how do I represent? Here is a particular encoding. Okay, I haven't told you what JSON is, but this is a JSON representation about an object. So you can see that I actually have something I call product. And under product, I have four different lines. And okay, I want to say that you see that there's a curly bracket, a pair of curly bracket in the black. And then there is a double quote, which is a string I call the product. And then there is a colon. And after the colon, I have another pair of curly bracket. And then inside the second pair of curly bracket, I have a four lines, and each of them is begin with a string and with a colon, and then have another string, and then have a comma. And then that's what they have. Okay, four line. So this particular representation, I'm not saying this is the only way to represent an object or this is the best way to represent. By the way, you can think about you have an infinite way of representing an object depending on what perspective about this particular object you would like to represent. So in this case, I care about the brand and I care about what I call group ID. And I care about the name of the product, and I care about something called UPC14, which is a 14-digit code to represent uniquely every single product. Okay, so that's just one way to represent. Okay, it doesn't have things like what's the percentage of alcohol in this box of beer. Of course, it's important if I want to represent whether a junior, which is somebody under 21 or 18. In fact, I forgot about exact age. Okay, so whether somebody who is not 21 or 18, whether they're allowed to purchase this beer, or somebody with a health issue or addiction problem to alcohol product, and this doesn't provide that kind of information. But anyway, this is a starting point. We can represent this particular product using this representation. And then the thing is that I have to think about who actually own the product. Is it sometimes you want to represent the object? So it's not just the object, but I want to know where this object is, who actually own this product. And in this case, there is, by the way, I'm using Nage Market. Nage Market is a very popular, very nice grocery store in Davis, where I live for 24 years. By the way, when I record this video, I'm actually in my home, in Davis. So, so this is called Nugget Market. That's actually about 10, 15 minutes walk from my house. Okay. And you can see that I call it here, I call it from. I mean, well, where I'm going to get this box of beer. I didn't provide too much information, but just have a store. The store is called Nugget Market, and I have some kind of identity. Okay, again, this is a simple representation of our market. I could have add more. For example, what's the address? And what's the revenue? And what's the reputation? Or what's the complaint or praise about this place? Or what's the what who is his manager? So all this information potentially could be included in a object that's represent a grocery store. So the previous slide, we actually represent the product, and now we have a object that represent the market itself. And so with this two, you already know you have a product, you have a nugget, and now we potentially can say answer a question like what are all the product that currently being sold in this nugget market. Okay, so you can see that I represent the object. Now I can have all this information. And this is a little bit more is that, well, if you think about a purchasing, somebody actually purchased a box of beer, and now I can actually represent a transaction. A transaction. A transaction is there is an activity when a person purchase a product at particular place. So this part, in fact, there is a concept called coupon. I don't want to get into the idea of a coupon. Coupon in Chinese is called 折价券, but that's okay. We're not going to look at that. But essentially it's saying that okay, uh, Felix Boo, who is a customer, I actually use a coupon with 25% off at this particular time at this particular store, I purchase this particular product. So you can see that this is an object as well. But this object contains at least three different objects. The first object is what is the store. The second object, what is the product? And then the third object is, well, who was the person who actually purchased this particular product? And then there is a bunch of information. By the way, this is the object. This is the object have only one, what we call attribute, represent what's the discount. And this is the object represent a timestamp to say when will this particular coupon expire. And then we have a time when this coupon was issued, and we have a message saying that how many percentage is the beer. And then we have some kind of subject we call coupon. So you can think about this as a coupon, but you can rearrange all this semantics about information. You can represent a transaction. You can represent a moving of a product from point A to point B, or somebody who has some kind of commercialization activity. Okay, so that's a object-oriented modeling. Essentially, you try to look at everything. So in this case, we look at a product, a store, a person, and we look at a transaction. Each of this, I model those as an object. And then you can see that this is very flexible. If I want to add another thing, I just modify this. By the way, this is called JSON. I'm going to tell you exactly the syntax about JSON. But here you can see that, okay, for example, I want to say, hey, where's the Nugget market? And then I'm actually going to add another attribute here called address, colon address, sorry, double quote address, double quote, colon, and then I provide whatever address. Or I want to provide what we call GPS. I mean, in case you don't know, GPS is Global Positioning System, which is a two floating point represent every single point on Earth. Okay, GPS. If you do Google Map, oh, let me show you what this is. If you go to Google Map, you can see I'm actually here in Davis. By the way, this is where I live. I actually live right. Wait a minute, where did I live? It didn't show my current address, but I live right here, right now. And here you see is Nugget Market. Okay, it's a Nugget Market. If you click Nugget Market, you see this two number. This two number is what we call GPS location. Okay, so the 38.56164 and minus, this is called latitude, this is called longitude. Okay, so latitude and longitude represent exactly what you are. We will talk about, you will learn about the GPS location in greater detail later. You can think about a lot of, for almost every single object, the GPS location is so essential for as a piece of information to solve lots of problems. Okay, so that's what we have. And then if you want to see where you guys are right now, come on. It's always fun to learn this. So let's get it. Okay, Tainan. I think we're almost there. Tainan, Tainan. Okay, where I am? Oh, NCKU is here, and this must be electrical engineering. I believe we're here. Okay, this is where you guys are. Okay, and then you can say this is your GPS location. 22.99669 and your longitude is 120.22248. Okay, so that's, and then later we'll calculate what's the exact distance between from NCKU Electrical Engineering Building to Nugget Market in Davis, California. I mean, this is exactly how Google is using this information to decide how to navigate us from point A to point B. Okay, right, let's get back to PowerPoint. Okay, so here I just want to tell you that yes, we can represent the object using this particular simple format, which is pretty flexible. You can imagine you can add. I mean, it's not pretty. Okay, when you look at this, it's not like the picture in the right on the right, but it's actually contain all the essential information that you care about those objects for your whatever problem you want to solve. And more importantly, a typical object-oriented system you can always extend, meaning that, okay, I actually define this product as such, but later I realize, okay, I need more information about the product. No problem. I just add another line over here, and then I will be able to have that. Okay. All right, so that's what I want to do. The first thing I'm going to talk about is called object. I mean, how do you describe an object? That's the core issue about object-oriented programming. By the way, object-oriented programming, this is my view. I'm biased, by the way. Object-oriented programming is not so much about programming. It's more about description about the object. How do you actually represent the object? Because that's really driving everything. It's not just your control flow, your if then else, your while loop. Those are controlling some of your action, how you're going to do that. But the core, the beauty about object-oriented programming is representing the detail about the object. That's what I want to emphasize. And today I want to talk about JSON, which is, stands for, as I mentioned earlier, called JavaScript Object Notation. It is a very common way of representing the object. It's so common, I would say that usually, if you think about all the information being exchanged on the internet, there are two representation. One is JSON, one is XML. Those two are the most popular way of specifying the information being communicated on the internet itself. But then when the information go across the gateway about a data center or a server area, then basically there is no XML. Everything left is JSON. So essentially, JSON is the most important representation for all the data that we have to deal with. Amazon, Facebook, Google. If you look at, by the way, if you look at your web page, look at the source code, you will actually find a lot of JSON over there. Okay, but first I have to tell you what JSON is. The good news is JSON is very simple to know. Okay, is the rule is actually very simple. Okay, here is JSON. So the key thing about the JSON is what we call key value pair. Okay, so take a look at, sorry. So it's called key value pair. If you look at JSON, you have a list of key value pairs. So what's the key and what's the value? So the typical key value pair is separated by a colon. So before the colon is the key, and the key must be a string. So therefore, this string must be double quote. So essentially, when you look at the JSON, it must start it with a key which is being included in one pair of double quote. And then you have the colon. After colon is what we call the value about that key. So that's what we call key value pair. I mean, let's go back to the previous example. I mean, for example, over here, I have a store, and this store is the key. And then after that is a value. In this case, the value is a string, because if you see a pair of double quote, that's a string. And therefore, this is a string, and the value of the string is not in market. So over here, the key value pair have two things. One thing, the key must be a string. The value has a type. That value in this case is a string, which is in this case is not in market, but it could be something else. I mean, for example, in this case, discount. The the key is discount, but the value is a number, is not a string. Is a 0.75. So it could be a number, it could be an integer, it could be a floating point. Or in this case, that the value could be an object. So what is an object? An object is actually anything between a pair of curly brackets. So in this case, the core, what's the core, is a object. And inside the object is one or more key value pair. All right. So in this picture, I have a bunch of key value pair, but I have in this case exactly have a three different value type. The first one is a number. The second one is a string. The third one is a object. Okay, so you can see that key value pair, and the value could be anything, could be not anything, could be different kind of value type, and the key must be a string. Okay, let's go back here. Okay, so you have a bunch of key value pair. This is an example about object, about GPS object. Okay, so GPS object, for example, you have two key value pair. Remember I said when you go to the Google map, you click on every single address is represented by two floating point. And in this case, latitude is the key. And the value is a number, 38.53. And longitude is the second key value pairs key. And then the value is minus 121.74. Okay, so that's the address. And of course, if I want to say where I live, then this is actually, you see that this is my home address. So the key is home, but inside is an object because the value is an object. And inside the object, I have a two pairs of key value pairs. And that represent exactly the information I put it there. So there's a few things. It looks like a bit complicated if you first time look at it, but the basic unit about a JSON is a key value pair. What's a key? What's the value? But because the value itself could be object, so that object might contain more key value pair in this case. So key value pair could be just a single flat layer, and it could have multiple layer. I mean, even for this example, you can see that I have a bunch of key value pair, but one of the key is front. And the value for this front key is actually an object. And this object contains three pairs of key value pair. And by the way, all the key value pair within the same object, they're separate by a comma over here. Okay. All right. So this give you some basic idea about what the JSON looks like. It's really just key value pair. And then you have to worry about where you should put the curly bracket, where you should put a bracket. Later we'll talk about bracket. Bracket in JSON means array. So this is not just about key value pair, but you can have an array of things. Okay, so this is so then we talk about the value type. Okay, there are seven different value type for JSON. Seven. So that's pretty good. You only need to deal with seven. Okay, if you know the seven, you don't have to worry about anything else. Okay, so this is seven key value. So the key, remember, is always a string, but the what I call that, the value part could be one of the seven. So this could be a string. The value could be a string, as we see, and it could be Boolean, meaning that it could be true or false. So you could write a JSON saying that the key is married, and then the column after column, you could be true, you're married, or false, you're not married. Okay, for example. And then the value could be an integer. The value could be a double. In fact, both of them are number. Okay, both integer and double are number. But later, when we write the program to deal with the JSON object in C++, that you do need to separate in cases about what is that number. Is that number exactly is an integer or is a double? That has to come out as well. Okay, so two of the type number three is integer, type number four is double, and type number five is null. I mean, this is just like the null in C programming language. Is null means there is nothing. Okay, so we have to have that. Okay, so now 1 to 5 is a basic type, right? You have a string, boolean, integer, double, and null. And number 6 is called array. So you could have a value which is really array of things. So you could have array, and array, as I mentioned, is represented by a pair of bracket, and within the bracket you have a bunch of value. Okay, so that's an array. And then you have an object. An object means that is represented by curly bracket, and such that within a value could be object such that within that object you have a bunch of one or more pairs of key value pair. So you can see that all of them get back is key value pair, but the value itself could be an object which is including more key value pair, or the value could be an array which you have a list of value that you want to include it. Okay, so that's the representation. I mean, with this seven um, uh, value type, You can imagine, particularly with the notation of object, that you can represent very complicated stuff. So now let's get back to this one. So now I hope you have some basic understanding about a JSON object. So this, remember I said, if you have a pair of object, this is an object. So by the way, the whole thing is an object. Okay, the whole thing is an object. And within this object, how many key value pair do I have at the first level? The first level, I have a 1, 2, 3, 4, 5, 6, 7, 8. I have 8 different key value pair. And their keys are discount, expiration, from, issue, message, product, subject, and to. So I have 8 different key value pair. And then the value part, the first one is a double. The second one, expiration, is a string. And the third one, the key is a from, and the value is an object. And then the fourth one, issue, is a string. And then the message is also a string. And the key product corresponds to what? Is an object. And then subject is a string. And then to, the key to, is also an object. So in this case, we have double, string, and objects consist into whatever the object we have for this particular representation, whatever higher level object you want to represent. So you can go many different level, such that if you use this simple language of key value pair with this 7 different value, you can imagine you can represent very complicated stuff. Okay, you can represent very complicated stuff. Okay. Okay, this is another example about JSON representation. It's essentially representing a bunch of a person. Okay, a person. For example, you could have a key called first name. You could have another key value called last name, and you say is alive, is a boolean, true or false. And then you have age, which is an integer, and you have address, and the address is an object. Okay, the address is an object. It has street address, city, state, and then postal code. And then you have a phone number because you have a multiple phone number, so they use array to represent a phone number. For example, you have a home phone, which is, okay, each of the value in the phone number itself is an object. Okay, it just say it's a value, but you could have a value of an object. So you have a two object. One is a home phone, one is office. And then you have a how many children do you have is an array, but this array is empty. And apparently, this person is currently single or not in a relationship because his spouse is null. Okay, so over here you can see that I have first level, I have a 1, 2, 3, 4, 5, 6, 7, 8. I have 8 different key value pair, and I have a value as a string, as a boolean, as an integer, as an object, or as an array. And as null as well. I have a null as an example. So you can see that with this 7 basic value type, I can do represent a fairly interesting representation about this person. Okay, by the way, I want to emphasize the concept. I'm just representing the information about the person. I didn't say anything about what kind of problem I want to solve. So this is a kind of shifting about programming style from the traditional procedural programming into object-oriented programming. We're focusing on the object. How do I represent a person? And then how do I solve the problem is really solved by seeing that this particular object will interact with another object, which we will see that in the later. Okay. Okay, we already done this part. how many way I represent this picture, you can think about. Okay, so now I want to do this. So now you have basic knowledge about what is a JSON. So now I'm going to move to the next step. I want you to make sure that you can work with JSON using C++. Okay, so remember the first time I asked you to do WSL, I did a lot of installation, right? Sudo apt-get install, make install GCC G++. And now we're going to do one more installation, which is the JSON CPP. Okay, JSON CPP is basically JSON for C++. And for Mac user, you need to go to this particular website is using something called Brew or Homebrew. Homebrew is a very nice software package management system to help us to install, remove package. So that's for Mac user. If you're a MacBook user, you should actually go to this website to follow the instruction there. If you have any question, let me know. But for WSL user, if you're using Ubuntu, here what you need to do you need to do, of course, whenever you want to get something, we always do this two things. First is sudo apt-get update, and then sudo apt-get upgrade. After you've done this, you just do this. You do sudo apt-get install. You want to install this is called libjson-cpp-dev. Okay, this is a JSON CPP development. And this line will help you to install the JSON CPP. And just to make sure you're installing the newest version, you can also do sudo apt upgrade lib JSON CPP dev. Once you've done all four lines, then you should have a good, reliable environment which allow you to do JSON CPP programming. Okay, and I do want to say that this is related to the makefile. If you encounter error later when you run G++, they say, okay, the file JSON/JSON.h not found error. If you encounter this error, most likely you need to add this line in your makefile, which I will show you in a minute about the makefile I'm going to give you. You need to add minus capital I slash user USR include JSON CPP, which I will later tell you that why you need this line, why you encounter this error. But at this moment, you just know that sometimes you see this error after you do the installation. Don't panic. It can be easily resolved. By the way, for almost most of the error in the compiler in the C++ environment, it can be easily resolved. And the thing is that if you encounter error message, uh, if you cannot figure out from Stack Overflow yourself, just please ask me or the TA, and we will guide you through that process. After you solve this kind of error once or twice, you will be very fluent and you will be able to solve this similar type of error in the future by yourself. Okay. And this is what I said. If you want to do this minus capital I, where you're going to change it, usually we change the C flags. In the C flags, instead of putting minus G, by the way, minus G is if you want to do debugger, you need to put a minus G to have more information. You change from minus G to minus G, then space minus capital I slash USR include slash JSON. Okay, so that's the thing. Okay. Okay, so now I want you to do the following. So you should go to GitHub. Where's my GitHub? Okay, here is a GitHub. Let me go back. So here is a GitHub with the EE1520. And inside here, I'm actually already include a bunch of file. Okay, you just using this option code, you said download as a zip. As I mentioned, okay, you need to learn how to download the file from the GitHub to your environment, and then you can actually do whatever that we repeat what we did in class. Okay, so download the zip and then unzip it, and then you do whatever the program. By the way, I did a bunch of update. You can see that I have already three sets of PowerPoint slides. I have a bunch of file, which is a CPP, for example, EE1520, common exception. Right now, you don't need to worry about the detail. I'm just basically want to show you a make file and how you can use a program to verify whether your JSON is a valid JSON. Okay, so you can see that all the program, all the make file that we have used this semester will be included in this directory. And by the way, over here you see I have a three make file. One is was the make file we used last time, and now we are going to have a new make file called makefile underscore JSON. Okay, we're going to do something. So now I'm going to open up my terminal. Okay, I'm in this directory. So this is essentially everything that we actually just uh, downloaded from the GitHub directory. Okay, all right. So over here, I want you to know one thing. Right now, my focus is that, well, how do I know? How the center question is, how do I know my JSON is actually a valid JSON? Means that I need to have a way to check the syntax about this JSON I just put it together. So the JSON that I have in the class is the beer. Okay, so this is the JSON I told you is the Nugget Market and has the beer from Bex, and then has this person called Felix Wu. So this is a JSON that's over there is exactly what we just talked about in the PowerPoint slide. Okay, so how do I know whether this JSON syntactically is correct? Because remember, if you make a mistake in the JSON, then the system won't be recognize your object correctly. And then that will be either it will fail or it's actually disaster because it totally misunderstood the information. By the way, I'm just telling you this could be really horrible. Assuming you have an object, it's actually represent is on an airplane or is on a drone, which is carry a very important mission. If you represent the incorrect information, I'm sorry, your airplane might crash. So therefore, it's very important to make sure that we know the syntax about the JSON in such that you can represent correctly. I'm going to show you first the program for you to test your own JSON. And later, when we teach the C++ and JSON programming, you will know how we actually did that. Okay? Okay, so I'm going to do, because I'm using a different makefile called makefile JSON, you should take a look what the makefile JSON looks like. You see that this is a bunch of things. It's a little bit different from the JSON file we used last week for compiling stack01.c. Now this is about C++, so you can see that the capital CC now is not GCC, is G++. I'm using the version of a C++ is C++14, was developed by 2014. Okay, and you can see that I have a C flag, which is including the minus capital I flag I mentioned earlier. And then I have a bunch of rule. I still have all which is the rule is called generate a executable called EE1520 parsing. I want to parse, and you can see that I have a bunch of program that's a bunch of rule. The rule generate the target is E1520 parse.o, JSON.o, exception.o, JVTime.o, and then finally I put everything together to generate this executable, and then I have a clean rule. Okay, so let me just try to clean that. Minus capital F, make file, JSON, clean. Okay, I cleaned it. I mean, the difference is if I do this, that will be the default make file. You see, these two are different. If I do make clean, is clean the stack executable. This was the program we used last Thursday. But if I say make minus F make file JSON, that means the minus F flag is actually direct the make program to look at a different make file, which is that make file is make file underscore JSON. So you can see that when I file the same rule, they're actually the action part is different. Okay, so now I'm going to make all. You see it started compiling this program and is generate the executable called E1520 parse. It compile a bunch of programs. So if I do dot slash E1520 parse, and it says, no, this program, you need to provide me a JSON. You need to provide me a JSON, which is I need to provide. Okay, fine. If you look at, I have a file called beer target.json. So I will do beer target JSON. It basically say, hey, I parse the JSON. There's no error message because the return code says 0. So everything is fine. So that means this particular JSON, beer target.json, is a valid JSON. Okay, let's actually modify a little bit. Let's make it error, make it a mistake. Let me do this. This will be a really interesting experiment. I'm actually use this as a beer target 2. And then I'm actually going to coming over here. I'm actually going to do copy and paste. What? So, oh, wow, I hate this. It basically introduced me lots of extra character. Let me get rid of this. Should have done this earlier. There will be some surprise. I mean, if you look at what I'm doing, do you think this JSON's okay? While I'm typing, I hope you can take a look at what I did and tell me whether this is a good JSON or is a valid one or is invalid one. If it's invalid, I can give you a hint. This is invalid even after I remove all this strange underscore character, but I want you to know why. I'm almost done. Okay, I'm actually putting in here. So this is, take a look. This is the information. Looks like I'm just copying. It should be the same. So let's try to run this program again. I'm run this, and now this time I'm against number 2. So now you see it give me what I call fail to parse the content. And the first JSON arrow is in line 7, column 2. So let's actually look at what is line 7. This is line 7. What's wrong with this? What's wrong with this line? Okay, by the way, this is the first column. This is the second column. So it's column 2. There's something wrong about column 2, about this part. What was the error? What was the problem? Okay, I can tell you the problem is this is not a correct double quote. This is a double quote. It goes straight. I actually don't know what to call this. You see that? This is double quote is actually has a with a slope. This is like the Romans, Italian character, whatever. So I have to change this to the regular. Uh, um, okay, now let's actually try to compile again. Try to run it again. It's still an error. Wait a minute. Line 7, column 2, still? Are you sure? Ah, I know what's going on. This is a bit tricky because over here I have another double quote, which is for some reason it gave me the wrong line, but this one need to be straight as well. Okay, now you see I passed that line 7. Now I'm going to line 15. Line 15. Here is line 15. You see that? There's another double quote which is with a slope. I have to change that. And are there any other double quote, which is okay? This one is also double quote with is not the correct one. And the final one is this one. If I correct all the double quote, oh, 23. What is this? Line 23. What was that? Oh, this is, I forgot to get rid of one space. Okay, now I don't have any problem. Now let me show you another one. If you forget the comma, okay, I forgot the comma, I get rid of the comma. I don't think this will work. See that? It has a missing a comma or a curly bracket. So you have to have a comma over here. And you cannot go, of course, if you're missing, you put a bracket instead of curly bracket. This will give you an error as well. It says that it's missing that on line 18. Okay, if you get rid of this, then you should have a good. So essentially what I did here is I gave you a tool called ECF1520 parse for you can use this program to try to write a JSON. You can write when you write a JSON, you're actually writing an object that you want to deal with. And then using this tool, EE1520 parse, that you can parsing the JSON and see whether you learn to write a valid JSON syntax to represent the data. Okay, that's what I want you to do. So I want you to do two things after you listen to here. Number one, I want you to go to GitHub to download everything, from this directory. And then number two, I want you to do is you need to probably more than two things. I want you to install. I want you to install the JSON CPP package or library, because if you don't install this library, then that program won't compile. The JSON, sorry, the EE1520 parse won't compile. So you have to download this, install, follow this particular slide, and then you can do a make -f, make file underscore JSON whatever, it should build a executable EE1520 parse. Once you've done that, then you follow what I show you the last part of this lecture, that you can actually run this program. I mean, E1520 parse, beer target 2 is just an example, but you can create whatever JSON you like. And then you want to test it syntactically, whether you have to learn to write a correct JSON. Okay, once you learn how to write a correct JSON, you basically already done the most important part about object-oriented programming, which is representing the data. Okay, so I hope you have a good week. I will see you on Thursday. I'm sorry I cannot be here, but I'm looking forward to see you to continue object-oriented programming learning for all of us on Thursday. Okay, you have a good week and talk to you later. Bye.